Okay, welcome to this lesson, which is surface area. So if you've been following some of the other ones, we've been looking at volume, which is the amount of space which is inside a shape. And now surface area is the area which is outside a shape. So we're looking at maybe the front and back, the side and side, the top and bottom. So these are all of the different areas that you get, and the volume is how much you can put in. If you want to really think about it, the volume is how much kind of water you could pour into a box or balls or whatever it is, and the surface area is the amount of paper that you'd need to, or cardboard, to create a box. So let's have a look at our first question here. Find the surface area of this cuboid. Okay, so first of all, it's worth thinking about the fact that with this cuboid, I'm just going to switch to. So with this cuboid here, you have the front and back, which are the same. You have the left side and the right side, which are the same. And you have the top and bottom, which is the same. So when we've got this, we only actually need to work out one of the front, one of the back, one of the side. And then because you've got ones which are all the same, we can literally just times this by 2. Remember to copy this into your book. Remember, it's the copying and the thinking about this question which means that you'll understand it. If you're just trying to watch the video, it's not going to work for you. Okay, so let's have a look at this first shape here. So we've got a cuboid. Sorry, cuboid. Now I did mention with this, if you want to draw a cuboid, you draw a rectangle in the front. You go up and right and draw a rectangle there, and then you connect all of the points to give you this cuboid. So the front face of this is equal to 6 centimetres. The side face of this is equal to 4 centimetres, and the depth, and then the height of this is equal to 8 centimetres. So we're going to break the surface area up into 3 parts here. We're going to break it up into the front, the side, and then the top as well. Okay, so the first thing I'm going to do, I use highlighters for this when I'm doing this. The first thing I'm going to think about is this front face here. I'm going to highlight this part here. And I'm actually going to label that. I know you can't see that very well, it is green. I'm going to label this face A. Okay, that there is face A, and that's the green face A. So I'll do this on the side. Face A. Put a circle around it. So with face A, it is a rectangle, and we've got to think about the dimensions of this rectangle. So the width is 6, and the height of this, it doesn't say here, but it's going to be the same as the back, which is 8. So the area of that one there is going to be 6 times by 8, which is equal to, we'll do it on a calculator just to make sure, don't want to make any mistakes, 6 times 8, which is equal to 48. Now, make sure you're using the correct units on this. The units on this are centimetres squared, because it's area here, centimetres squared. So that's the area of that front face A, which is 48 centimetres squared. Now let's have a little look. You might want to highlight it in green, just so you know. That's that one there. Okay. Next one we're going to look at, we'll look at this, let's say the side here. So we're going to look at this face here. And we're going to call this one here face B, let's say. I know you can't see that very well, I have highlighted that in yellow. So this one here is face B. So let's write this on the side. So this is the area of face B. Just do a little circle there. And put that one in yellow. So, face B, the dimensions of this are 4, and the height of this is 8. So this one here is going to be 4 times by 8, which is equal to 8, 16, 24, 32. So 32 centimetres squared. So the area of this right hand side here is 32. The area of the front is 48. The last one that we can kind of see here, the one we're going to deal with, is going to be this one here. So we'll highlight that in blue. This one here is going to be, let's call it C, for example. So with C, face C, which is our top, could call it, we've got to know the dimensions. So the dimensions of this one is going to be here and here, or this front one here and here. So here we have our width of this rectangle, which is 6, going to be the same as this bottom down here, and the depth of this, which is 4. Now, some people do find this hard to see, but it's going to be 6 across and then 4 up there, same as this here, 6 and the 4. So it's going to be 6 times by 4. I'm going to highlight that in blue. So 6, 12, 18, 24 is equal to 24 centimetres squared. So now we know the area of this front face, we know the area of this side face, and we know the area of this top face up here. Okay. Now there's two ways you can think about this now. You can either times each of these by 2, so A times by 2 because you've got the front and then the back over here. You've got B times by 2, which is going to be this face here, but also this face here. And you've also got the top and the bottom, so it's C here, but then also underneath here. So each of these have got a matching face, so the front is matched to the back, the right side is matched to the left side, and then the top is matched to the bottom. So you can times each of these by 2 and then add them together, or you can add them all together and then times by 2. And actually I think it's a little bit easier just to add them all together and times by 2, but you're not going to make any mistakes with this. So it's going to be equal to 48 plus 32 plus 24, and because there's a matching face for each other, all of this is going to be times by 2. So it's going to be 48 plus 32 plus 24, which is equal to 104, times by 2 is equal to 208. Now we do need our units on this. What are the units on this one? The units on this one, because it's area, are going to be centimetres squared, like so. So that's the surface area of that shape there. I am going to do a second one of these. Very, very similar, to be honest. Very, very similar. Not that much different. The only difference really is that the only real difference is the dimensions. So I'm just going to go through this one really, really quickly, just in case. Remember to get this written down as example 2 in your books. Example 2. Okay, so here I've got my cuboid. It's quite a long rectangle in the front. Notice that this one goes up towards the left here. So it's worth going up and left. I can overlap them, there's no problem with that. There's up and left, and then connect, 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 and connect. So we've got the front, which is 10 centimetres, the depth, which in this case is 5 centimetres, and the height of this one, which is 7 centimetres. Again, I'm going to label it A, B, and C, front, side, and top. We're going to highlight them. We can highlight them straight away. Just highlight them before I do anything, just so I know it's all sorted. So there's A highlighted. Don't know if you can see that very well. There's B highlighted. And then the top one, which is C, which is highlighted as well. So let's work out face A first. So A, which is my yellow face, and the dimensions of A are 10 by 7. So it's going to be 10 times by 7, which is equal to 70 centimetres squared, because it's the area of that front face. For B, which is this one here, highlight it in green. So with this one here, again, you've got to think about this. It's going 5 back and it's going 7 up. So it's going to be 5 times by the height of this, which is 7, which is equal to 35 centimetres squared. And then C, a little bit trickier to see this one. But the width of this is going to be the same as the width of the bottom, which is 10. And then the depth of this here is 5. So this one here is going to be 10 times by 5, which is equal to 50, again, centimetres squared. Because we've got matching pairs of all of these, so the front and the back, side and side, top and bottom, we need to add all of these together and times by 2, front, back, side, side, top and bottom. So it's going to be 70 plus 35 plus 50 times by 2. So 70 plus 35 plus 50 times by 2 is equal to 310 centimetres squared. And that's that one done. Nice and easy. Okay. Let's, if you are doing foundation or you are finding this a little bit tricky, maybe pause now and skip to the end and have a go at some of those questions towards the end. If you want to push yourself a little bit further, you want to try something that's a little bit harder, I'm going to move on to things which are going to be working backwards now. So if you really want to push yourself, have a go at these next 2 questions. If not, then maybe skip forward a little bit and have a go at those last questions. So, next 2 questions here. We've got the... so here we've got a question which is given the surface area, so you're already given that surface area. Find the value of x. So with this one here, I'm going to draw it out again first of all. Notice that this one goes up towards the left. So remember to copy all these questions down. This would be example 3. So here we've got our rectangle at the front there. We go up and left this time. Draw a similar rectangle, congruent rectangle I should say. And then we connect all those sides. And here we've got 10 centimetres. The height is 8 centimetres. The depth here is x. And it tells you already that the surface area of this is equal to 268 centimetres squared. So, I would do this in exactly the same way. The only difference is that you are doing it in terms of x. So you do all the things the same, you create that equation because you know it's equal to the surface area, and then you work backwards to solve. So let's label it exactly the same as I did before. So the front is A, B, and the top is C. I'll highlight those. Sorry, that's not very clear there, but I think you know what I'm talking about. A is there, B is on the side, and C is on the top, which is there. So let's work out the area of A first of all, which is this front face. So A is going to be 10 times by 8. So 10 times by 8, which is equal to 80 centimetres squared. 80, sorry there. B, now this is where it gets a little bit tricky because the depth of this we don't know. We do know the height, which is 8, and the depth, which is x. So it's going to be x times by the height, which is 8, which is going to be equal to 8x. Again, this is area, so it's centimetres squared. Just because it's 8x, it does not mean that it's not an area anymore. And then the top part, well, this one here, the width of C is 10, and the depth of this is equal to x. So it's going to be 10 times by x, which is equal to 10x centimetres squared. So we have got things in terms of x, but don't be worried about them. Don't be nervous about that. It's just these are just expressions. We do exactly the same. We're going to add this, and then times by 2, and that's equal to our surface area. So here I've got 80 plus 8x plus 10x times by 2. And I know that's equal to the surface area, which in this case is 268. So what I need to do with this now is I need to simplify it as much as I can and then work backwards to solve. So the only thing I can do at the moment is bring these two things together. So it's going to be 2 times by 80 plus 8x plus 10x is 18x, which is still equal to this, 268. Now you've got two options here. You can either expand this bracket and then solve, or you can divide by 2, then take away the 80, then take away the 18. I'm going to expand it. So 2 times by 80 is equal to 160. 2 times by 18 is equal to 36x, which is equal to 268. I remember I'm trying to find out what x is, solve to get x. So the first thing I need to do is get rid of this 160, and I do that by minusing, keeping this balanced, minusing it from both sides. 160 minus 160 is going to mean that's gone. 268 minus 160 is equal to 108, so I end up with 36x is equal to 108. Last part, to get rid of this 36, this means 36 times by x, so I'm dividing by 36, dividing by 36, so 36 divided by 36 will just leave you with x, and 108 divided by 36 is equal to 3. What are my units on this 3? Well, this is a length of 3, so it's going to be 3 centimetres, not centimetres squared, 3 centimetres. Remember, we did exactly the same here. We found the area of the front, 8 times 8, which is 80. We found the area of the side, which in this case was equal to 8 times x, so 8x. We then found the area of the top, which is 10 times x, which is 10x. We created this equation. This is probably the hardest part. So, front face, side face, top face, all added together. All times by 2, because you know that there's going to be side and side, top and bottom, front and back. We then simplify this, expand the bracket, and then we solve like a normal equation. Okay. Honestly, I think that's probably harder than the next question I'm about to do. I think this one's a little bit more tricky to think about. There is the other option of obviously finding the areas about these first, but I think this is probably the easiest way to think about this. So let's go on to the last question now. Now you'll notice this is a completely different shape. So because this is a completely different shape, we need to think about it in a different way. The thing we need to think about is what areas do I actually have here? So we've got the front, we've got the back, which is the triangle and the triangle, so we can work out the area of that. We've got this length here, she'll go it that way. We've got that length there, which is one we've got. But I don't know what the dimensions on that are. I just don't know what they are. So there is a way to do this. Now, I do notice on this that there isn't a right angle there. I'm assuming that's a right angle. That's probably my fault. I should have put that right angle in first. But let's draw this now. So I've got my triangle, which is there. Exactly the same way as I draw any prism. I go up, I go right, and I draw exactly the same triangle. Connecting the top, the bottom left, and bottom left, and bottom right, and bottom right. And let's label this now. So it's going to be 8 centimetres, 6 centimetres, and the left here is 9 centimetres. This is example 4. Remember, you should be writing this in your book or writing it somewhere, whether it's a revision guide or whatever it is. So this is example 4. Okay. So, with this one here, I can work out what this one is here. So let's highlight this one here in blue. Because that there, the area of that, is quite straightforward to work out. I am going to put in here, even though it's not on the diagram, I'm assuming this must be a right angle. Okay, That'll be a mistake from me. So I can work out the area of this triangle. In fact, I will do that now. Let's call this A. Okay, I'm going to call this triangle A, just to make sure that I know what it is. What is the formula for the area of a triangle? Well, the formula for the area of a triangle is base times height divided by 2. So this one here is going to be 8 times by 6 divided by 2. 8 times by 6 is 48. Divided by 2 is equal to 24. This is equal to the area of this triangle in front is 24 centimetres squared. Now, there is also this triangle on the back. Okay, so we've got this triangle here, but we've also got a triangle on the back. So we do need to make sure that we have both triangles, and they are going to be identical. So we've got the 7 by 8, again we've got the 7 by 8. So straight away, I might as well think about that now. So the triangle at the back is also going to be, I'm going to label this back triangle. You could just times by 2. It's going to make it really clear. The back triangle is also going to be equal to the 24 centimetres squared. So I think that's probably the easy part. The next thing I need to think about is this bottom here. So this bottom bit here. Now this bottom here, I think is quite straightforward as well. And this bottom here is going to be 9 times by the 8. You see here, this is the bottom 9 times by 8. So let's write here, bottom, and that's equal to the 9 times by 8, which is equal to 72 centimetres squared. That's fine. Now, we also need to think about this back here. So this back here, you can see that in this one here, I'll make it a little bit bigger. There is a point here at the back, okay? So this face, this rectangle, which is the face up. Now this one here is going to be 6 high, and it's going to be, how deep is this? Well, it's 9 deep there, okay? So the back of this, let's say, this one here, the back, I mean, you can call these whatever you want. I might want to label them if I want as well. So this is back, this is bottom, like underneath, okay? This is triangle A. This will help the examiner know what you're talking about, okay? So the back here is going to be this height, which is 6, times by the depth of this, which is 9. So this is going to be equal to 6 times by 9, which is equal to 54 centimetres squared. Now, the last one we need to do, I'm going to highlight this one, is going to be this top kind of a slanted face here. Let's highlight all of this. Okay, so we've got that bit highlighted there. This is in green. I'm going to call this maybe the slanted height. You can call it whatever you want. Or maybe just label it as C or whatever. But with this one here, that we have a problem because we know the width is 9, okay, or the depth on this, which is 9, but we do not know what this one is here. Okay, we don't know what this length is. But we do have a right angle triangle here. Now, if you can remember back to when we've done this, if you want to find out the third length of a triangle, you need to use Pythagoras. So here we've got, let's draw out the little triangle, just so we can see it. We've got that there. We know this is 8 centimetres, we know this is 6 centimetres, and we're trying to work out this one here. So, we use Pythagoras, which is, we label our triangle first, A, B, opposite the right angle is always your hypotenuse, which is C. Pythagoras is A squared plus B squared is equal to C squared. So we end up with 6 squared plus 8 squared is equal to C squared. Let's do that. 6 squared plus 8 squared is equal to, that's equal to 100, which is quite nice. Do not forget to square root at the end, okay? So 100 is equal to C squared, so C is equal to the square root of 100, which is equal to 10. 10 times 10 is 100. So I know that this length here, and it's probably worth writing this on now, is equal to 10 centimetres. And then we can do this last one. Let's call this one maybe C. So C is equal to the depth, which is 9, times by this length here, which we've just worked out using Pythagoras, which is 10. So 9 times 10 is equal to 90 centimetres squared. So then here we've got the front triangle A, we've got the back triangle 24, we've got the bottom of this, which is a rectangle, which is 9 times by 8, so 9 here times by the 8. We've got the back here, which is 6 high, and then it's 9 deep, the same as this part here. And then this top one here, this was the hard one, this is what makes this a little bit trickier, is the fact that we don't know what this is, but we can use Pythagoras to work this out. So it's going to be 9 times by 10, which is the 90, this rectangle on top. Last thing we need to do to work out the surface area is add all these faces together. So 24 plus the 24 at the back, plus the 72, plus the 54, plus the 90. So the total surface area of this is equal to 264 centimetres squared. So that is a little bit harder, okay? That's that one done. So let's have a go at practicing some of these now. So have a go at these questions. Pause now to have a go at those. Okay, and have a go at these are the answers right here. So unpause now and mark those in green. Okay, we've managed to get that sorted now. So I'm just going to transition into this. So have a go at these questions. Pause now to have a go at those. Okay. Okay, and there's the solutions. Have a lovely day.